Hello everyone, welcome to another video. So today we're going to do area and volume of geometrically similar shape. The keyword is geometrically similar shape. So this thing only works for shapes that are similar. Okay, so but before we start, we need to go to this so-called simple diagram to illustrate the whole concept here in one good diagram. So we're looking at a ratio of volume or area or length of similar shapes. So there's a way to convert the ratio of length, area and volume to one another. And the question requires you to do this quite often. So for example, if you read this from length, the ratio of length, if you want to change to ratio of area, you got to square both numbers. So from length to volume, you cube both numbers. And similarly in reverse, if you have the ratio of volume, you want to get length, you cube root. If you have area, you want length, you square root. So the question is, how on earth do we get area to volume? You can't. So what you do is from area, maybe you change to length, and then you go and cube to get back the volume. So this conversion is the crux of the whole concept. If you can do this, then this whole thing becomes very, very easy. So let's start with a standard question. Okay, so let's do this question as a start. So again, the keyword here, see, again, the small cylinder is geometrically similar to a large cylinder. This is the keyword. You see this, you know this is the concept. And then they give you what? The height. The height of the small one and the big one is 8 and 20. So this 8 and 20 is the ratio of the length, because a height is a length. It's not an area, it's not a volume. So this 8 and 20 is the ratio of length. Okay, so let's look at what they ask you. And then they say what? Oh, the smaller one, the circumference is 24. Now 24 circumference is length. And then the large one, find the large one. So basically, you given ratio of length, you want when the small one is 24. So this is very similar to map scales and ratio in general. So let's start. We got 8 and 20, small and big. This is length. And the question wants also length. So from 8, how to change to 24? Times 3. So by common sense, also times 3. That's the answer. Finish. Simple. Now let's look at B. So in B, they are asking you for the ratio of the volume. So what do we have? We have this length. And I need ratio of volume. What do we do based on this picture just now? From length to volume, we cube. That's it. So look at part B's answer. We start with 8 is to 20. So we make it simpler first. So we reduce, lowest term, 25, I bracket length. Now I want volume. What do we do? These two numbers, we simply have to cube. So 2 cube is 8, 5 cube is 125, and this is the answer. Finish. Okay, next, they say both cylinders are filled with sand. Now, when you fill with sand, we are talking about volume still, correct? Volume. So they say what? The mass of the sand is, or the small one is 250. Find the mass of the large one. So same thing, because we're talking about volume, we start with here, volume. So 8 and 125 we start. I still want volume, and then what? The small cylinder is 250. So this is small, this one needs to change to 250, and then this one will change accordingly. So so from here to here, we don't have a nice number to multiply, so we simply do primary school maths. If I were to make this 1 and then make this 250, I simply divide by 8, then times the number I want, right? So I'm dividing by 8 times 250. So here I'm doing the same thing. So this number divide by 8 times 250, I calculate is 3000 something. And of course, oh, did I not do 3SF? Okay, we should do this 3SF. Huh? Okay, so that's the question. So you can see that this is very simple to do. Let's look at another example, and you will quickly realize they are all the same. Okay. Okay, let's start. So same thing, we have 2 whatever. Again, geometrically similar, this is the keyword. And then the ratio of the base areas are 9 and 4. Now this is area. So in this case, they give you the area. Just now, in the previous question, they give you the length. Okay, so I have the area. Then let's read. Part A, the area of the top, this one, is 540. Find the area of the smaller one. So this is still area. So what I do is I start with the big and the small, 9, 4. And then because I still want area, I simply got to change the big one to 540. So from here to here, 540. So what I do is I divide by 9 times 540. So this number also divide by 9 times 540. This is the answer. Easy. Next, I want the ratio of the depth. So depth is what? It's the length, right? How deep it is. It's a cm, it's a length thing. How long is a cm thing. So I need length. Okay, so find ratio of larger to smaller, and I want the length. So I only have 9 and 4, and this is the area. So based on our picture, from area to get to length, I need to square root. So square root of 9 is 3, square root of 4 is 2, and this is the ratio, and I have length. From area, I square both numbers, I get length. Finished. Now let's read. Now both of these are filled with sand. Now filled with sand means volume. Correct. So volume. So now I need volume. And then what? Find the mass, and the smaller one is 2.4. So I start from here, I have length. But now I need volume. So what do I do? From length to volume, I cube and cube. So 3 cube, 24. 2 cube is 8. So this 27 over 8 is to 8 is the volumes ratio. And then I read the question, what do I want? I want the smaller one is 2.4. So this one needs to be 2.4. And then this one will change accordingly. So same thing, divide by 8 times 2.4. Divide by 8 times 2.4. And then this is the answer. Finished. So this is exactly how to do questions like this. It is actually very, very simple. So hope you learned something. Thank you and bye-bye.